Hello students, welcome back to my YouTube channel Data Shah. So we have started with the new series of the transportation problem, and in the last lecture we have discussed what is a transportation problem. So we have various methods to solve the transportation problem, and the first method that we will be talking about in this lecture is northwest corner method. Now, in the northwest corner method, it is a method adopted to compute the initial feasible solution of the transportation problem, and as the name suggests, the northwest corner. So we'll be starting from the extreme left corner, and what would be the different steps I'll be talking about. So let us consider one example. Let me take this question. You have to find out the solution. You have to find out the minimum cost using the northwest corner method. Now, the northwest corner method, that means we have to start with the corner, and these are the cost that is given to us. Now, how could we solve it? In this, the supplies, the destinations that we have are A, B, C. The sources is given to us. So these are the sources. These three are the destinations. The supply and the demand. Now the first thing that we have to find out whether the demand is equal to supply. So as it is given to us, it's 600. So it becomes a balanced transportation problem. So we could say that as the summation AIs, this is I going from 1 to 3. So these are the AIs that I have is equal to summation J going from 1 to 3 BJ. So these are the BJs. So therefore, it is a balanced transportation problem. Now we come to the steps. Now, as we'll be talking about the northwest corner method, so we have to start with the extreme left corner. So this is our extreme left corner. So now what we have to do here, we have to consider this point. Here we'll be talking about this is 6, that is the cost that is available to us. Now we have to find out the number of units that would be required from the first source to the destination A. So what's the demand? The demand is 200 and the supply is 150. So if the supply and the demand, we have to select the minimum of that. If the supply is 150 and the demand is more, so obviously we have only 150 available. So I'll be writing here 150. So this supply, that means now I have allocated here 150 units, and more than that cannot be allocated because this is the only supply that I have. So I'll mark it as 0 because 150 minus 150 becomes 0. Now in the demand, because 150 has been given, taken from the source 1 to the destination A. So I will just deduct 150 from here and I will just write 50. This step will be proceeded further. Now where should I move? Should I move to the next column, that means this, or should I move to the next row? Now if I move to the next column, in the next column, do I have any supply? No, there is no supply. It is already 0. So if the supply is 0, can I move to the this row, this first row? The source 1 has already met the supply. So we'll not be moving to these columns. So we can't move here. So I'll be not considering it. So I'll just delete that particular. I'll be moving downwards and I'll be talking about the source 2. Now in the source 2, again, the demand is 50 and the supply is 175. What is minimum? The minimum from 150 and 175 is 50. So there are 50 units that could be taken from the source 2 to the destination A. So for destination A, the maximum demand that they could meet is only 200 units. So you would see that 150 and 50 becomes 200. So I'll just cancel it and I make it 0. And here I just subtract 50 from it. So it becomes 125. I have to repeat the same process again and again. Now I can't move downwards. So this cannot be done. Let me just cross it with another pen. So I cannot go down because demand is 0 now. I can't go here. So I'll be moving in the next, I'll move here. So here it would be again, we have to choose, the demand is 100 and supply is 125. To choose the minimum is 100. So I can take only 100 units and this would again become 0. This would become 25. Now, can I move down? No, I can't move. So I'll just make a cross here. I can't go down because the source 2 and destination B has already given the 100 units. So can't move further. Now moving ahead, in this 25 is the supply and the demand is 300. So obviously when the supply is 25, that's the minimum. So I'll be just taking 25 units to the destination C from the source 2. So this becomes 0 and here just subtracting it. So it becomes 275. Now, whenever we are doing the transportation problems, we can always check the last allocation that we will be having would be having the same demand and supply. Here also you will see I am having 275 demand and 275 supply. So this shows that my answer is correct. So this is again a form of checking how whether your solution is correct or not. So this is our northwest corner method. And what would be the minimum cost that we'll be getting? The minimum cost that I will get here would be 150 units. So the 6 is the minimum transportation, the 6 is the C11. So that's the cost per unit from source 1 to destination A. So I'll be multiplying it by 150 units. So then adding 50 into 7. So the process remains the same. You have to multiply the number of units with the cost and just add them all. Plus 275 into 12. So when we add them up, I'll be getting here the answer as 5925. So this is 5,925 is the minimum cost of this transportation problem. Now, one more thing that I have explained in the last lecture was the basic feasible solution that we have to calculate m plus n minus 1. So is it equal to m plus n minus 1 or is it not equal to? So let us check. M is 3, n is 3 minus 1. So that's 6 minus 1, which is equal to 5. Now what is this 5? These are the positive allocations. So allocations means 1, 2, 3, 4 and 5. So as we are having 5 positive allocations, this is we should have, and we are also having it in our answer. So that means this implies that we are having a non-degenerate basic feasible solution. So this is how we can find out the initial basic feasible solution. So let us consider the second example here. So in the second example, we have the sources, 3 sources X, Y, Z, and the destinations A, B, C, D, E, 5, and we have the demand and the supply. So the first thing that we have to check whether it is a balanced transportation problem or not. So we'll add this. 4 plus 8 is 12, plus 9 is 21, this is 10, and plus 11, 21. So it's a balanced transportation problem. Now let's consider. We'll start with, these are the cost that is given to us. So it could be given in this way also. Here it could be given like this. So now we have to find out the number of units. So the process remains the same in the northwest corner method. We have to start with the extreme left corner. So the minimum of 3 and 4. So the minimum of 3 and 4 is 3. So I'll be allotting 3 units here. So this becomes 0, and here it becomes 1, 3 minus 1. So I can't go down in this further column. So I'll be moving here. So I'll be talking about this. So minimum of 3 and minimum of 1. So the minimum is 1, obviously. So this supply becomes 0. The demand is now 3 minus 1, that is equal to 2. So now remember that we can't go down here. So I'll be not be considering this. I'll be considering this. Again, I can't go here. I'll be going down here. So let me just mark it with a different color pen. So can't go here because now for the source X the supply is 0, so I have to go down. I can't move further in that particular row. So now moving ahead in the next one, this would be minimum of 2 and 8. So the minimum is 2, and this would become 0 again, and 8 minus 2 is 6. So now moving ahead, I'll have to move. Can I move down, or I'll be moving here? So the source Y still have 6 units available with that. So the supply is still there. I can't go down, so I'll not be considering this one. So I'll make a cross here because the allocation has been done for this destination B. So moving ahead, minimum of 4 and 6. So the minimum of 4 and 6 is obviously 4. So for source Y going to the destination C, I can only have 4 units. So let me take red color pen. 4 units available, and then this becomes 0 and this becomes 2. Now can't go down, so moving here in this direction. So minimum of 5 and 2 is obviously 2. So this becomes 0. This is 5 minus 2, 3. Now going down in this, I'll be taking 3 and 9. So the minimum of 3 and 9 is obviously 3. This becomes 9 minus 3, 6. So you will notice that in the last allocation that we have 6 and 6, the demand is equal to supply. So this is 6, so it becomes 0 in both the case. So now I have taken this route. So this is visible clearly. And what would be the minimum cost? The minimum cost is equal to 3 into 2 plus 11 into 1 plus 2 into 4, 7 into 4, 2 into 2, 8 into 3 plus 12 into 6. So the answer that we'll be getting here, we could calculate it easily. So this would be 6 plus 11 plus 8, 28, 4, 24, and 36. So the answer, final answer that we'll be getting here would be 153. Now we have to calculate whether it's a non-degenerate basic feasible solution or a degenerate. So m plus n minus 1. So we are having the m is 3 plus 4 minus 1, that's 7 minus 1, 6. So we could check out that we have 6 allocations, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and sorry, this was 5. My mistake. So that's 5, that's 8 minus 1, so that's 7. So we are having 7 positive allocations. That means again we are having a degenerate basic feasible solution. So let's take another example. In this, again, it's very simple to calculate. So first of all, the first step is to check whether it's a balanced or a unbalanced transportation problem. So we could easily calculate 7 plus 9 is 16, 16 plus 18 is 34. Again here 8 plus 5 is 13, and 13 plus 17 we are getting is 13 plus 17 is 30, and this is coming out to be this is 34 and this is 44. So that's an unbalanced transportation problem. So how do we deal with the unbalanced transportation problem? So I'll be talking about it in the next example. This also we are having, as you could see here, this is 200, 350 and 150. This is 700, and this is 100 plus 140, 300, 250. This is we are getting it as 240, 540, and this is 790. So as summation AI is not equal to summation Bj, so therefore it's an unbalanced transportation problem. Now, how to deal with the unbalanced transportation problem? For the unbalanced transportation problem, we always have to add the dummy row or the dummy column. Now, how do we decide whether we have to add a dummy row or the dummy column? As we knew, in the supply was 700, it was less, right? This was 700 and this was 790. So to make them both equal, I have to have here 90 more supply, and I would be having a dummy row here with 90 supply, so that I can make it 790. So what would be the cost that would be available to me? It's all zero. So I'll be adding a dummy row with all the zero cost, but with the supply 90. But if you have an example where your summation AI is less than your summation Bj, then you will be adding a dummy column similarly. So in this case, let us consider starting with the left hand side, 100 and 200, the minimum is 100. So I'll be allocating 100 units here from X to A. So this becomes 0. So I'll be moving here on the next destination B. For X, it would be 140, and this becomes 100. So the minimum from 100 and 140 is 100 obviously. So this becomes 0, and I'm allocating 100, and this becomes 40. Now going down in this, so minimum of 40 and 350, obviously 40 is the minimum, so it becomes 0 and it's 310. Now moving ahead, I can't go down in this particular column, so I'll not be considering this one, so I'll be moving ahead. So 300 and 310, 300 is the minimum, so this becomes 0, and I'll cancel it, it becomes 10. Now again I can't go down, so this would be 10, and this is 250, so obviously 10 is the minimum, and this becomes 240. Now 150 and 240, 150 is the minimum, so this becomes 0, and this is 90. So at the end you will see 90 and 90 is what I am getting here. So the route that I have taken, you could easily identify. Now if we'll be checking our m plus n minus 1, so m plus n minus 1 here would be, we have 4 destinations and 3 sources, so it would be 7 minus 1, that is equal to 6. We could easily check here that we have 6 allocations, and because here is a dummy variable, and to make it equal, so it would be 8 minus 1, that's 7. So I am having a positive number of allocations as 7. So again I am having a non-degenerate basic feasible solution, and in this one the minimum cost that I will have would be equal to 16 into 100, 1600 plus 1300 plus 520 plus 5700 plus 150 plus 1500 plus 0, because this is the dummy one, so it has a zero cost here. So these are the cost. If you have any confusions, this is the cost. And so we could find out the minimum cost that we'll be getting here in our answers, and we could calculate it as well. So I'll be getting here the answer as 10770. So these are a few examples of the northwest corner method, and in the next lecture we'll be talking about the another method of the transportation problem.